Hello and welcome to Deep Learning Leaders. My name is Eric Landau and I'm the CEO and co-founder of Encord, the data development team built for AI teams. I'm thrilled to be joined today by Amarjot Singh, the founder and CEO of Skylark Labs, who are providing state-of-the-art AI systems needed for land, air, and sea defenses. Thanks for joining me today, Amarjot.
Thank you very much for having me, Eric.
Excellent. So I wanted to start today just by going over your background because you have a pretty unique background and seem to come into the deep learning space from the perspective of the human brain, which I think is quite fascinating. But I would love just to start to hear your story and how you ended up founding Skylark Labs.
Yeah, so I started working on AI specifically for security applications during my PhD. I have always been very interested in safety and security applications because my dad was in the Indian Defense, and I saw a lot of these security applications and the impact they can have on national security. So a lot of my interest was piqued from that. But also, growing up in India, I saw a lot of challenges faced by women from a safety and security perspective, as well as children being kidnapped and moved around to brothels. So I was very motivated to solve all those challenges. So that's the topic I picked during my PhD, mathematics and AI applied to security challenges. But all of these things happen on the edge. So you wanted
Mm.
AI which would be able to process the live video stream or data stream coming in real time and give you real time decisions and not after the fact. And when I was started doing my PhD, which was in 2015, we didn't have the fancy packages like PyTorch or TensorFlow. I had to write every line from scratch, and we needed AI, which could also do these things in real time. So I turned to neuroscience, where I studied the human brain, which is a great machine. It's data efficient, it's computationally efficient, and can process things in milliseconds as opposed to the models at that point. So that was my motivation as to how I turned to neuroscience to find answers which could solve real world problems.
That's really interesting. So right now the paradigm of AI is um, it's I think inspired by the brain, but there's a lot of disconnect between how humans think and how current, especially foundation large language models run. You know, they require much more data than any human needs. They're much more computationally intensive than any person as well. What do you think we're missing in the deep learning space from the gap between the human brain efficiency and the current state of the art models that we're seeing?
Yeah, so I think the one thing which I really focused on during my PhD was actually trying to figure out why the brain is able to do these things or these tasks so well as compared to our AI models. So one thing which came out of my research was that the fundamental architecture, which is being used for every application in the world, is end-to-end supervised, and it has billions of parameters, and the number of training samples which you need to make this model learn something meaningful is proportional to the number of parameters, and then you need
Hmm.
proportionally large data sets. While the brain does not require that because it has this hybrid architecture, which is part fixed, part unsupervised, and part supervised. So that is what I did during my PhD, where I came up with this hybrid architecture, where since you only had couple of layers at the end, which was supervised, the number of labeled data sets which we need were accordingly limited as compared to the traditional deep network. So I think if you think in terms of um, large data sets needed in current applications, that's a limitation fundamentally of the architecture, and it's totally supervised. That is not how the brain is. And that is the gap
Mm.
I tried to fill during my PhD.
How much of it do you think is it that the brain has so much inherent knowledge and structure already kind of priced into itself? So, you know, when you're born, that's hundreds of millions of years of evolution kind of in the wiring as well versus data that you learn after you're born, either albeit in a unsupervised or supervised fashion. Do you have any kind of view on the mix there?
Yeah, so definitely can comment on the visual target recognition, object recognition
Mm,
space. So if you look at the brain, and it starts from the V1, which is on the initial layers of the brain, and then it starts to go deeper. So the first few layers, they have edge-like structures, which can be straight lines, which can be curved lines, things like that. Those are pre-built. And then beyond that, you are able to like put them together to make complicated shapes. So
hmm
from the experiments which came from Hubble and Wiesel, which they did, for which they got the Nobel Prize as well, uh, at least the first few layers, which are basic concepts, they are built. But beyond that,
mm.
we are able to build them very quickly using unsupervised learning in the early young age, and then it goes to supervised tasks.
So similar to how, people are, they're using an architecture for the initial image embedding to get the low-level features, but then they stack other models on top of that to do task-specific applications. I'm curious on just to get your take, and just because you've studied the human brain, it's a topic of interest for me as well. Uh, how do you think the brain learns in an unsupervised fashion? Do you think it's similar to how these large language models are learning, where you're trying to predict the next instance or the next word or the next kind of visual cue? Or is there some other method with which unsupervised learning happens from your experience?
So I think human learning is very interesting. So the traditional models is you have to give it a lot of experience, which is batches of your which is batches which you get from your large data set. So you keep on giving this experience, which is in batches, and over a period of time, your model learns. But if I tell you something right now, whatever you're learning from me, you are able to learn it within seconds, right? And the reason for that is we have this top part of the brain, which is the neocortex, which is similar to a deep network, which is learning everything long term. But we also have
Hmm.
this hippocampus, which is a small part of the brain, which is your fast learning system. So whatever I'm telling you, it is able to learn right away. So the brain learns things at different temporal scales. That's one.
Hmm.
Also, the data distribution, the experience which we have is quite unbalanced. How many times you're going to be seeing a tiger in your real life? Maybe once or twice, and you saw it maybe in your school textbooks, but you don't really go and see it every day. We see people every day, but we still have the ability to differentiate them well. But the other thing which is very interesting is you have a golden retriever, I have a golden retriever. You know a lot more about your golden retriever, what the dog likes, the behavior traits, things like that. But when you see my golden retriever, it's like, okay, it's a golden retriever. So also we learn information at multiple scales about
Hmm.
experiences which are more frequent. So the learning of the brain happens on two primary ways. One is the things which we see most frequently, we have a tendency of learning them. And things which are more recent, we have a tendency of learning them. And the hippocampus can do a great job. I tell you right now, you can remember it for a week because it's very recent. But if I repeat it again and again, then you learn it permanently in
Hmm.
your neocortex. And that's what kids do in school as well. You go, you practice something, you have a higher tendency of retaining it. But if you don't practice, you don't have frequency, you're not going to learn it. So it's primarily a factor of frequency and recency.
Hmm.
But interesting thing is there's also a factor called importance. For example, you
Hmm.
call someone the credit card agency. They tell you their name by training. As soon as you put the phone down, forget about it. It's a very recent event. Or you're playing cards with someone. You have a card set of cards in your hand. As soon as you throw it down, you forget about it. So the brain also is very selective in how it puts importance on things. And we don't really
Hmm.
know how that does it. So, but yeah, but frequency, recency definitely are the reasons why we are able to learn things.
And what do you think we're missing in the current set of architectures that we could
Yeah.
actually be utilizing from the way that the brain, does well, kind of importance and attention, and that we don't know necessarily the mechanisms, but in terms of recency, in terms of
Yeah.
repetition, like what are the kind of inspirations that we can take?
So the main networks which we had, they were end-to-end supervised. So the only way you could learn something is if it was presented to you again and again and again. So it had to be really frequent.
Hmm.
And if it's not, if there is one or two samples in your data set, you're not going to learn anything. But I can tell you something and you can learn it. So the reason why we're able to do is the hippocampus. So there are new models now, which are memory augmented networks, where you have a
Mm.
memory attached to it. So if I show you something once, your deep network is not going to learn anything, but you can encode that knowledge into your hippocampus. So if I ask you the question regarding that again, you are able to answer it from the hippocampus. And if you see it again and again and again, then you can encode it into your deep network. So there are variations of that, which are memory augmented networks, which are able to do human-like learning. But then there's more research which can be done. For example, the memory right now is simply a buffer, but the hippocampus is parametric. So you can do
Mm.
that. And once you put something in the hippocampus, when you sleep in the night, it goes and it's replayed to your deep network. So what do we replay? Do we replay things which are frequent, which are recent? Do we replay things which we are really bad at so that we can reduce the loss very quickly? Or do we have
Mm.
some a mixture of all that? Those are the kind of open research questions which people still do. DeepMind does a lot of that. It goes into AlphaZero and AlphaGo and all of that stuff, where we are learning from experiences which can be single or which can be repeated, but we have the ability to use them.
Um, what do you think the human loss function looks like in the brain?
That's a that's a very good question. So I think that also ties into the importance factor, right? So if you look around and you don't recognize something, and if it is not important to you, you don't really care. You're like, okay, maybe it looks like a car, maybe it looks like a bus. So similar to our deep network, if you push something and if you know 10 classes, it's going to try to map it to one of those classes, unless you don't really know anything about it, right? But if I really
Mm.
force you and I say, hey, can you really pay attention to that? And see what it is, and then you can start to be like, I think it's a variation of car, and then the class starts to develop. So I think still it's a factor of attention and importance. And if you start to really use your attention, then you can imagine like the gradients flowing. After that, you're
Hmm.
able to like either assign a new class or have it as a subclass or something like that. So that's how the best way I can think of.
Yeah, no, that's really interesting. I could talk about this, I think, for hours, but I also want to go into Skylark Labs. So, what prompted you to, start a company versus continue your work in academia? And I'm curious to learn more about what you guys do at Skylark.
Yes, so I finished my PhD where my total focus was on building AI, which could learn on the which could run on the edge, which was data efficient, computationally efficient. And the first project I did after finishing my PhD was in India, where the aim was to rescue children which were
Mm.
kidnapped from brothels, from weaker sections,
Wow.
and pushed into brothels. So the aim was these kids are kidnapped at age 10, 12, and then they're pushed into brothels at age 18 and made to do
Wow.
prostitution. So there is a very big age difference between the picture in the data set and the picture which you see in the wild using cameras, which is not a phased frontal picture. So we built AI which was running on an edge device, which could give you matching with the data set, and then would also tell you whether the child is minor or not, so that the nonprofit could go and raid that brothel to rescue children. They saved 13
Mm.
children so far using our system,
Wow.
which is great. Yeah,
Yeah.
but what we realized was that there are a lot more people in the brothel than pictures in our data set. So we
Hmm.
wanted to like figure out that how do we important flag these uh, key important pictures or faces. So we relied on frequency. Okay, this person is there all the time, so probably he's the brothel keeper. Or this is a child which is now being seen frequently, so this is probably a new child. So the key thing which came out of that was when you're deploying these systems in the real world, you're always going to see new concepts, new signals which were not covered in your data set at all. So
Mm.
that motivated me to join Stanford University, where I was a postdoc. My work was funded by DARPA. I was part of the Lifelong Learning Machines program of DARPA, where the key idea is how do we build machines which don't just work for the data set I know, but if there are new things which can come outside of the data set, how can the machine learn them using a single exposure on edge in real
Hmm.
time and keep on doing it? So I left Stanford almost 3 years ago now. And the aim of Skylark is to build this next gen AI, which doesn't just work for the signals or concepts we know. If there are new things which can come up, it can learn them in real time as well. And we decided to apply it to the most crucial applications, which is defense, where the cost of missing a signal can be catastrophic.
Yes.
You can't go and adapt the system in a traditional way where you go and retrain it and then redeploy it. And that's what we do, and we deploy it across several defense applications on land, sea, and air.
Got it. And so the this kind of adaptive AI system, it takes inspiration from the work that you did at Stanford and with the kind of architecture of the human brain, or is there some other kind of component that comes in to really enable this to actually work on unseen types of data?
So there are three things which come into play. One is that you can only learn something new if either someone tells you, which will be after the fact once the damage is done, which is usually
Hmm.
what you read in newspapers that okay, there was a cyber attack and this much data is leaked, and now we got to go and reinforce the system so that that doesn't happen. That doesn't help because the damage is already done. So in our system, it's two pronged. One is that okay, if there's a new signal learning in the input space, which is somewhat similar to the concepts which we have in the data set, but it's not exactly similar. So it can be a new
Hmm.
variation. It flags it. And then based on whether there's a human in the loop or not, the system can automatically add it as a new class or a subclass and then can keep on learning it and adapting it. And that's how we do it. So it's all based on the human learning framework. It's a memory augmented network, but we have different kind of
Hmm.
principles which allow it to learn new information without forgetting what we have learned.
Interesting. So I'm sure there's a lot of deep ideas that are applied there because it is quite a difficult problem. If you're looking at data outside of your input distribution, it's very hard
Yes.
to extrapolate the shape of these things, and you can't really say much about the network behavior, at least in the paradigms that we've worked in. I'm curious
Yeah.
how you validate a system like this and how you ensure that it works, and what kind of what kind of frameworks that you have in mind, if it's any different from kind of the traditional train test validation splits that you have in other frameworks.
Yeah. So I think like that is where it's complicated, but the key idea is that um, you're trying to, so your standard model is learning the whole shape and is trying to optimize that, okay, if it's somewhere around the mean of the bell curve, I'm going to
Hmm.
do really well. If it is
Hmm.
minus sigma to plus sigma, I can still do well. But when you start to go towards the extremities, that is where your model collapses. That's one.
Hmm.
So we are trying to find things, new things, which have some sort of commonality with either one of the concepts we know or it has some partial similarity. For example, rather than learning the shape of the whole car, which has the tires, the bonnets, the windscreen, we run part-wise models, which has tires, bonnet, windscreen, things like that. So, and when we're trying to find something new, we can say, well, it has like 30% similarity to the car class because it has two of these parts. Or it
Hmm.
is a new type of vessel class because it has two parts of the destroyer and two parts of the fishing vessel or something like that. So when we are
Hmm.
finding something new and learning something new, it is based on some sort of relevance of what the user wanted the system to learn. So it's not totally out of there, but we are just trying to generalize beyond minus sigma and 2 sigma because otherwise this model would not learn that. So there is still some
So
sanity in the system.
right. So does this approach make uh, the model naturally more explainable for you guys to understand why it's doing what it's
Yeah.
doing?
Yeah, so it does as well because it's so when we push a signal through the network, it's going through the standard deep network, and the standard deep network knows the answer. We're like, okay, great. But we also have this secondary network which is saying that, oh, I know it's the same answer because these parts are found in that. So based on that, we are able to say that, okay, this is a class one drone because of A, B, C, D features in that. And that's very important for us as well because when we are doing targeting, our specialization is looking at targets which are beyond visual line of sight, so you barely see the shape.
Hmm.
You see some parts here and there. So the more information we can give it to the user, the better it is. Do you hear
I
me,
think I
Eric?
lost. I think I lost you for a second.
Okay. Should I repeat it? I can do that.
Yeah, we can edit that. I think that's fine. So I heard up
Okay.
to see the past the line of sight.
Yeah, so our aim in most of our application is to find targets which are beyond visual line of sight, and these are mainly for targeting, whatever the user wants to do. So we don't want to just say, hey, I found like this class one drone, or this is a fisherman's vessel, whatever that may be. We also try to give you more information so that you're better equipped to take the decision you want to take, and it's important in
Mm,
defense applications. Uh,
hmm
so yeah.
and how much is the model? How much is the human? Is the model just informing the human to make the best decision? What is the kind of balance of judgment?
So we don't take decisions for the user. We only
Hmm
give enough information so that they are in a better position, so they have better
mm,
situational awareness. But there is no
mm.
work at all which takes the control from the human and takes the decision.
Yeah, I see. So, how is the shift coming from academic background, doing research, to actually starting a company? I'm
Yeah.
curious what that transition looked like for you.
Well, it's never easy
No.
because because I think the motions are very different because in academia your work is only focused on building something which is very interesting, which can really push the envelope or have the next advance in the field. But in a company, you're responsible to your investors, you're responsible to your employees, so you have to build things incrementally, where you build something,
Mm,
you test it, and then you build the next version when you feel like, okay, it's gonna lead to some sort of traction or revenue. So there's a target in mind, and eventually we want to be able to make the difference and make it a system which is widely acceptable, but also want to make sure that we are only going to places which can pay for the acquisition of these systems. And I think that comes into play, and that greatly changes your decisions of what you can or cannot do.
mm. And do you think there's anything that academics get wrong about AI, given that they are insulated from the real world application, either in the methodology or the
Yeah.
way that they think about the problems? Well, what do those look like in your view?
I think a lot. So I think, especially like applications like ours, if let's say you are working for OpenAI, or if you're working for Anthropic and you want to deploy your AI on large servers, you have similar kind of infrastructure available in your university. The data sets
Mm,
are similar. So when you're trying to deploy them, the data distribution you're trying to test versus you're trying to develop your system are quite similar. But when you go into domains like ours, there are a lot of constraints as to how fast the system should run, how fast the alert should go. Is the data distribution somewhat different? So there is always like this iterative change you have to make, and the systems have to
mm.
make themselves. And I think that realization is very hard to get in the university because you don't really know what the real world data set looks like. And you can't get access to the real world data set because of the
Mm.
limitations of working in defense and security applications.
And of course you do get need to have people pay for your model at the end of the day. So there's kind of
Yeah.
an approach different. And I'm quite impressed with your work in government and defense applications. It's quite difficult, especially for an early stage startup to get these types of engagements. So I'm curious if you
Yeah.
have any learnings or any advice for other companies that are trying to get government deals.
Yeah. So I think when I think about the go-to-market motions in the on the national security ecosystem, there are only two ways of doing it, uh, and you have either low TRL systems or you have high TRL systems. You
Hmm
can only have high TRL systems if you really have deployed it with some end user, you really understand what the problem is. So the easiest way to do this thing is to go and approach contracting instruments which focus on low TRL system. And there are entities like DARPA, Office of Naval
Hmm.
Research, Small Business Innovation Research grants, where you are able to do all of this stuff. And you get like a grant which is either for 200,000 if it is phase one, or a million or so if it is phase two, and you develop the minimum viable product for the government. And this is great because you're getting money from them to develop your solution. So there's a lot of support
Hmm.
from the government on that. So that's great. But moving that $1 million contract to $100 million contract is extremely difficult, because that is where your value of death is, because you have built your MVP, which is in the grant space. And now, when you want to be able to go and deploy this thing on the large scale, you have to commercialize your thing. You have to worry about three things. One is, okay, if you have a great software, can they use it? So do you have the cybersecurity layers around that, so that you can first of all put your system a software on their server? That's one. And getting those is difficult. It takes time. The second is, okay, if you're able to get the cybersecurity layers, how do you even put the stuff on the server? You need authority to operate, authority to test, which is expensive to get and it's time consuming. And the third is, if you have cyber, you can put the software there and they're like, great, we want to buy it. Uh, what contracting vehicles do you use? FedRANK takes a lot longer. There are other instruments like NASA Soup. You can get IDIQs. You can partner with companies who have IDIQs, so that you don't have to go through this very long contracting cycle. So companies never actually cross the valley of death, or they die
Hmm.
trying, because either they don't have the cybersecurity, authority to operate, or the contracting vehicles. I would say the contracting vehicle is the most important thing. If you're able to get that, your chances of crossing this valley would be very important. And the easiest thing to do that is to partner with defense primes, like we
Hmm.
partner with a couple of big companies, and that'll be
Hmm.
the easiest way to do. And once you have one commercialized contract, I think then you will be easy. It'll be easy to scale. But I think this understanding of what is needed when you go from the grant space to the commercialized space is missing. And that is where I think if companies can focus on that, it'll make their life easy.
That makes sense. How much education is required from your part to the actual stakeholders on the government side, or is that not a factor given things are going through structured processes?
So, no. So, there are a lot of contracting vehicles which are available even on the low TRL world. Um, and and there are ways of doing this thing. For example, the financial year is ending. Okay, there is some surplus funding remaining with everyone, so you can go and capture that. You get one piece in that allows them to buy more stuff, so you don't have to naturally wait for them to put out a problem statement. You can also go and proactively outreach to either the Office of Small Businesses, and each of the wings, whether it's the Marine, the Army, the Navy, they have their own innovation cells. So that is where the main demand signals come. So you can, if you can go and know those ahead of time, you are better equipped to win those. So
Hmm.
and there is like ways that as to how do you get there, because it's such a big innovation ecosystem. It's very hard to like figure out how do you actually go and get a capability review done, and so that you are able to win those grants. So I think there is a very significant learning curve. It took me almost 1.5 years to understand, okay, a lot of the things which I'm doing, they're not going to lead anywhere. So focus on these. It takes time.
Yeah, my usual advice for companies trying to get government deals is don't do it because it's so difficult, and it's especially anathema to early stage startups that just need to iterate quickly and they need to get signals from the market as fast as possible. So it's very impressive that you've been able to get the kind of traction that you have in that space, and I'm sure there's quite a lot to learn from how you work with partners and this gap between the kind of proof of concept and like the eventual full deployment of the contract as well.
Yeah.
I'm curious. maybe I'm just kind of understanding, have you seen perceptions of AI shift in since ChatGPT came out at all, and since the foundation model era, in terms of your users or your partners or anyone that any other stakeholder that's relevant, or is it similarly the same from what you've seen before?
No, there's a big change because with OpenAI becoming a system which we use every day, more people are aware that okay, AI is relevant, it's important, and there has to be more mainstream adoption of that in pretty much whatever we use. That's one. The second thing is there is also a big push from the China side because China has been
Hmm.
developing systems quite quickly. All of them are intelligent systems. So there is also a need for us to strengthen our AI infrastructure because other countries are doing that. So at least in the US, and we do a lot of work in India, same is over there as well. There is a very significant shift in policy related to national security, and AI is the fundamental piece in all of that, which is driving it. So yeah, it has been a big shift. Yeah.
Why do you think more people are not using adaptive AI in new use cases, kind of breaking the barrier of seeing new data out of distribution that they haven't seen in the training set, try to learn quicker? What do you think the gap is in the market? Is it education? Do they not know about it, or is there anything else that the public should be aware of?
So one is that there aren't commercial products which are available to the end user to be able to consume it. There are some in the cybersecurity space, and it makes sense that if you train your data on certain ciphers, the person who's attacking can always change them. But when it comes to the physical world, there aren't products like that because when you're doing it in the cybersecurity world, you're doing it on a big server. So it's very easy to, you know, freeze whatever you had learned before and learn something new so that you don't forget the previous information. But when we are doing this thing on the edge, we don't have data sets on the edge for all the things you had learned. And you get like this new information and you want to be able to learn that without forgetting everything
Hmm.
else. So there is awareness that, okay, if we could adapt the system, that would be great, but there aren't products available which allow you to do so. But this awareness is changing. There are problem statements coming from the US Defense, specifically US Navy, ONR, where they want to be able to make systems which can change themselves so that the cost of update is less, which is very significant in defense. So there. I think this shift is coming. So if you
Hmm.
think 2014 to now, 10 years, AI is everywhere. So I think the next big evolution, whether it is personalized chatbots or adaptive
Hmm.
systems in defense or adaptive systems in manufacturing, which can look at new or old effects, that would be adaptive AI.
Hmm. And what's the next priority for Skylark? Is it really kind of perfecting these systems? Is it scaling? Is it new kind of go-to-market partners? How are you thinking about the future?
Yeah, so for us, we are right at this key inflection point where we have a couple of solutions which are moving towards procurement. So once they're commercialized, that'll trigger next round of funding for us. That'll lead to more hiring, expanding into other verticals. Right now, we only do defense and we mainly focus on Navy, Air Force, and Army and DHS, but there are other agencies we would like to expand to, but also on the public safety side. You can do the same stuff with base protection, sheriff's offices, police departments, warehouses, industrial parks. So we have done some of that here and there, but we are trying to go from the most crucial problem where there is significant capital to develop, and then we'll start to expand into other verticals. And then I assume it'll become everyday thing because people will get a taste of it in other sectors as well.
Hmm. How do you ensure that the technology is used in kind of positive ways, or is there any way of actually doing that?
So, in the defense space, mainly our work is focused on observing and not offensive stuff. So that
Mm,
is one thing we are very focused on. But when the system adapts, there are multiple levels of checks and balances to make sure that the system has actually learned something which is meaningful and not something you didn't want it to learn. Although it might have some sort of similarity to the concepts, you know. So those that is how we are able to maintain checks and balances. So adaptability is there for the user to exploit, but it is constrained adaptability.
great. What is one thing that you wish to have known before you started a company? Is there anything that like, oh man, if I could go back and tell myself, I would have done it.
I think there's learning in everything. So when I started the company, I'm a single founder. So there were,
Mm,
so whenever I go and like do, I mean, there isn't a big challenge right now, but previously when I was raising capital, it's like, okay, it has to be founders and not founder. And I had built like a lot of the tech myself. So I wish like if I could go back at the very early stages, I would pick another person to work with that would make my life easy. Right now, we are like so late stage that that would not make sense for us. So that is one. The other thing is, I would love to like fail as quickly as possible and then
mm,
adapt as quickly as possible. We have been able to do that, but I feel like that speed or that cycle rate should be like ideally weekly. And you should be able to do the sprints and do that and then really focus on what really works. And sometimes we got stuck with doing things which we thought we could make it work. Primarily, that I guess comes from the academia world where you're used to solving very hard problems and you are
mm,
like, okay, it didn't work. We can try another way, but maybe they can be out of box things which you can do. And sometimes you just scrap the whole thing and you start again, which is not really what academia teaches you to do. Uh, and then the other is like simply people management. I think that is a very big part of building a company. Your early
mm,
hires should be really, really good. I think some of my early hires weren't as good because in academia we are used to like giving people more chances to evolve and adapt, and because you have more
mm,
longer timelines. While in the startup world, that is not the case, and your early hire, if it's wrong, if it's a B grade person, it's gonna hire C grade
mm,
person. So
mm,
so you need
mm.
to make sure that your early hires are good. So if I knew all that
Well,
stuff, that would be great.
it's all priced into the process of starting a company. What do you look for in early hires? Is there any kind of attribute or flag or signal that other founders should be thinking about?
Yeah, so I think like one thing which we really focus on is the culture fit, and I think like that is the most important thing, and culture is how more or less you define it. Some people focus on, okay, this is the attitude of all the people, and this is how you should focus on. For me, it's
Hmm.
a combination of attitude, work-life balance, being able to work with different departments of the company and have flexibility. I think that's a key thing. The major thing I've seen in some of the people we are interviewing, they don't really have the flexibility in their life for
Yeah.
whatever reason, or they have it but they don't want to exercise it. They measure everything to, okay, this is the amount of money I'm getting and this is the amount of effort I want to put. But I think that
Mm,
doesn't work in the in the startup ecosystem, because you want to be able to like stretch beyond the well-defined KPI boundaries. And I think that is just a mindset shift. So if you get the person with the wrong mindset, that's a problem.
yeah, and especially an early stage environment, there's so much ambiguity and uncertainty. You need people
Yeah,
that are going to thrive in that kind of chaos, essentially, and be able to build through
yeah.
it. So my last question, and we've touched on some of these bits, but what are you most excited by in the AI space?
That's a great question. I think the current era where we have companies like OpenAI, we have companies like Anduril, Shield AI, they are able to make significant impact on the end user and provide value using AI systems. I think that on its own is very exciting because that
Mm,
validates that AI is a machinery which should be incorporated in all software and hardware infrastructures. So that's one. But also that has been able to make a very significant impact, which would not have been possible without the use of AI, right? Gone are the
Hmm.
days when we could write enough if-else statements, right? So the other thing is like we are able to like do things or solve problems which would not be possible. For example, if you want to send a rover to Mars or Moon, you don't really know what the surface over there looks like. So you need to have AI which can adapt, or we have personalized chatbots, or we have crawlers, or we are able to analyze large amounts of data sets, whether it's from the intelligence community or you want to do trend analysis or whatever that is, or whether it is stocks. None of that would have been possible with the advancements in AI and chips and quantum and all of that stuff. So I think like all of these are very exciting advancements. And for me, the obviously the thing which really excites me the most is how do we actually go and replicate the brain in 10
Mm.
years from now so it can do everything which we can do. And right now we are able to do it in a piecemeal way. Okay, there's a vision system, there's a language system, there's an auditory system, there's a decision making system. But how do we actually put them together so that eventually they're able to like learn of each other as well and improve
Mm.
together so that we start to go towards what true AGI is. So that's the most exciting thing for me.
Okay, so I said that was going to be my last question, but maybe it's actually quite fascinating. What does AGI actually mean to you, and what do you think the implications of AGI are if we get to whatever your definition of AGI is?
Yeah. Yes. So I think it's a
Big
very
easy
it's a
question.
very
Yeah.
it's I think like based on like who you ask, I think you get a very different answer. And
Yeah.
from for me the definition of AGI is general intelligence first of all, which is achievable, and I think you can go and like increase the scale from there. But I
Mm.
think the most important thing for me is ability of a system to obviously continuously learn, like intelligent systems are able to do, how the human is able to do. That's one. But the second thing is being able to also validate that what you're learning using some mechanism is useful or not, right? So,
Mm.
um, and having awareness as systems is a very difficult thing, which we have not learned in an intelligent way. So that is still based on a set of rules. So, for example, I'm saying that okay, we are learning something useful because it has some attributes which are common to the concepts we have learned, and that is still a bunch of conditional statements. Is there an intelligent way to not just learn new things, which is
Mm.
model-based approach, but also validate that what you've learned is important. So there is also a reflection, and that is true intelligence for me as well. And also the thing is like whatever I'm telling you, you can learn. And if I dance in front of you, you are able to repeat those same motions. And that is mirror neurons in the brain where you're able to
Mm.
mirror my actions, right? And now if you have like five AI systems in different places, and one of them has really learned that, okay, I should be driving ABCD way so that my driving is safe. I don't want the other four systems to go through the same experience. They should be able to learn of the experiences of the first model. So that is knowledge based consolidation or improvement rather than data driven, which is mainly what we are used to. So you want to be able to adapt a system, go through data at it. But we don't always have data, and we shouldn't be even needing data. My teacher, my professor at Stanford, had learned a lot about neural networks over the past 50, 60 years of his time. I don't have to go through 60 years to learn the same thing. He can teach me using his knowledge in one go.
Mm.
So I think that is another thing which is very important, which we try to bring into some of our systems. But I think if we have continuous learning, reflection on what we are learning is meaningful, and knowledge driven learning as well, that'll
Mm.
be, I think, a good step in the AGI direction.
That's a really interesting perspective. AGI is not just functional capability, or it's not just measured in functional capability, but it's how the system itself learns, and
Yeah.
that's achieving an AGI system. That's really interesting. Well, yeah, thanks, Amarjot, so much for coming onto the Deep Learning Leaders podcast. Skylark Labs is doing some really exciting things in the space, and we can't wait to watch your continued growth over the next few years. And thanks so much for your time.
Thank you very much, Eric. Really appreciate, and thank you very much for having me.